Expressions are what separates your app from the out-of-box solutions to the custom-built apps perfect for your business. Yet I hear all the time how intimidating writing expressions can be, but it doesn't have to be like that. In my 6 years of training AppSheet developers, I've helped out thousands of people like you master expressions and build amazing business apps. In this video, I dissect the anatomy of expressions, helping you to understand how and why they work, so that expressions like this can be a fun puzzle. If you have experience writing formulas in Sheets or Excel, this is really going to translate. But trust me, for the rest of you, I was once in your position. We'll be breaking this down to make it really easy. What is an expression? Well, an expression is a formula-like statement used to return values or define a behavior in your app. Before we jump too deep into expressions, we need to talk about data types. In AppSheet, a data type refers to the kind of data that a column in a table can store. Let's check them out. Within the AppSheet editor, on the Data tab, you can find the data type for every single column. As we can see, the driver name is a name, key is a text, and so on. You have over 30 options to choose between. Not only do columns have data types, each expression you write will have a return value that must be a specific data type based on where you're applying that expression. Within the expression assistant, right here, you can see the expected data type. That means that anything inside this input requires to have a return type that matches email. To test this out, let's go ahead and put an invalid value. Let's say 12. Since 12 has a result type of number, it is not one of the expected data types of email. Let's try putting in an email. This function, user email, returns the email of the person currently using the app, which is a data type of email, so it is being passed in as a valid value. All right, let's dive in. What makes up an expression? You'll find expressions are made up of 4 components. There's constants, columns, operators, and functions. Constants are a static value that you manually type into the expression assistant. For today's examples, we will be using this field delivery template app. If you would like to follow along, click the link inside the description, press Manage, Collaborate and Publish, and then copy the app for yourself. Let's go ahead and go into the status. Within status, if we scroll to the right into the initial value, we'll go ahead and put in pending. This ensures that anytime a new job gets created, its initial value will be pending. Columns. These allow you to retrieve a value from a specified column in your app's data. They look like this. You'll see the name of a column wrapped in squared brackets. Columns return dynamic values. What this means is that based on where that num column is running, it returns different values. For an example, LeBron James's record, if you were to run that num column expression, it would return 23. However, someone like Kobe Bryant, on his record, it would return 24. To see this in action, let's look at Kevin Durant's. Kevin Durant's number is 35, and so on his record, that num expression would return the number 35. The next important feature is dereferences. Think of dereferences as a portal into a ref column. What this means is that in this example, we have NBA basketball players. At the end of the table, we have a reference to their team. The team table looks like this. Using dot notation for dereferences, you can use a team ID, or a reference column, in square brackets followed by a period, and then a column that belongs to that referenced table. Let's look at an example of this. For Kevin Durant, his team is Suns with the ID Suns ID. If we go to the team table and find the record where the key is son's ID, we can go to that record and retrieve the colors from it, which in this example is orange and purple. This expression would return the same colors for teammates. Let's say Kobe Bryant and LeBron James both play for the Lakers, so they both return purple and gold. If you want to hear more about this feature, we have plenty of videos on this topic down below in the description. For the column example, let's go ahead and create a new virtual column. For this virtual column, we want to label this one driver's phone. Since we just created this virtual column, it has no specified data type, and so no data type is expected. However, we called it driver's phone number, and so what we want to do is we want to return the driver of this job, their phone number. So let's go ahead and do an expression that does that. So if we were to start off just by putting in driver, let's see what that would return. For the driver, it simply returns the ID of that driver's record. No other information yet. But we can use the idea of a dereference to retrieve a column from the driver table. Let's go ahead and try it out. First, we want to do the period and then square brackets. If we wanted to return the driver's name, we could do something like this, and it would return the name of the driver who is assigned to this job. But that's not what we want. We want their phone number. So let's go ahead and add that. This is a common use case of a dereference. Whenever you want a child record to retrieve a characteristic from a parent record, you'll do something like this. Next, we have operators. These are broken down into two different families. We have arithmetic operators and logical operators. First, we have arithmetic operators. These allow you to apply math to an expression. Think plus, minus, multiply, divide. Let's say for an example, you wanted to find the net total. You could multiply the quantity by the price. Or let's say you wanted to find the average hours worked per day. You could take the total hours of the year and divide it by the number of days in a year. Next, we have logical operators. These allow you to compare two values. Remember, these always return true or false. Think like this. True or false, the quantity is greater than in stock. Let's say quantity of how many they sold is 12, and the in stock is 10. This would return true. However, if quantity was 5, it would not be greater than, so this expression would return false. Next, we have weekly hours is greater than 40. This is a column being compared to a static value. Last, we have status does not equal completed. This would return true if the project is not completed, but would return false if the status is completed. This could be used to say yes or no, is the project active? For our arithmetic operators, we want to go ahead and create a new virtual column. This virtual column, we want to label it completion duration. A fun thing about arithmetic operators is that they don't only apply to numbers or decimals. You can also apply them to dates, times, date times, durations, and lists. Okay, so we want to start off by entering in the drop-off date time, and then subtracting the smaller value, which is the pickup date time. This expression right here returns the duration of the elapsed time between the pickup date time and the drop-off date time. And our example of a logical operator starts off with us creating a virtual column and calling it in progress. We want to return a value of true if it's in progress and a value of false if it is not in progress. The way we determine if a job is in progress is if the status equals started. Equals is a logical operator. Let's go ahead and use it. First, we want to do status is equal to the constant text of started. This will return true for every single job that its status is started. Let's go ahead and check this out. Right here, we can see that all these are false currently on the screen. because we see canceled, pending, canceled, finished. Let's scroll down until we see one that is started. Right here, this one is started and it is returning true. Perfect. And last, we have functions. A function is like a pre-built command that helps the app return a value in a way that both you and the app can understand. When I say that we use functions to communicate in a way that both the app and us understand, it's like us speaking a language that we both share. But to speak that language, we have to follow a specific syntax. What is syntax? Well, syntax is the precise format and rules for constructing a function. Think of it like this. Function syntax will always look like this. A function name followed by opened and closed parentheses. In this example, you see within those parentheses, there are things called parameters. Parameters are inputs you plug into a function to control its return value. These parameters have a delimiter of a comma. That means that a comma separates each of the individual parameters. This is true for all functions. Function syntax is almost like learning a second language. What I mean by this is an English speaker beginning to learn Spanish would translate each word from Spanish into English so that he can properly understand what he's saying or hearing. An example of this using AppSheet's function syntax is this. In this select function, we are going to return a list of all users' emails where their role is manager, and we don't want to remove the duplicate emails. Another example is in this select function, we're going to return a list of projects, clients, where their status is not completed. But we do want to remove the duplicate clients. So this would look like a list of all the clients who have active projects. Any client who has multiple projects that are active would still only show up once. Being expected to know all this information can be a little daunting when you're constantly running into new functions you've never seen before. So we built this free dashboard to make all that searching easy. As you can see, for every function in AppSheet, we have the data type the function returns, as well as the parameter inputs required to build the function. We've also included all that information and a practical example in a short recorded video breakdown. For the in progress example, we talked about how we can return yes, no if a column is equal to another value. What if we wanted to see if that column was equal to this value or another value? Let's look at two ways we can do this. Let's go ahead and create a virtual column called closed1. We want this to return true if it is a status that means the job is closed, and false if it is a status that does not mean it's closed. This means that we want it to return true if the status is equal to finished or if the status is equal to canceled. Let's see how that looks. We'll be using the OR function. The first parameter is expecting a yes-no condition. For this yes-no condition, we're going to do status equals finished. The second parameter is also a yes-no. This one we're going to do status equals canceled. To convert this function into English syntax like we talked about, we want to replace the commas with the word or. This looks like this function will return true if the status equals function, the comma, or status equals canceled. Let's go ahead and create a virtual column for our second option. This one we'll call closed2. In closed2, we want to use the in expression. In the in expression, to convert it to English, the first parameter is a text you want to search for. The second parameter is a list that you want to search through for that first text. Think of it like this. The needle is inside of the list haystack. All right? So the needle is in the haystack. If this needle is inside this list, it will return true. Otherwise, it will return false. So the needle that we're looking for is not needle, but we're looking for the status. So if the value of the status is found in this list, and the list is going to be finished, is the first element of the list, and the second element of the list is canceled. So what this says is if the status of the job is in the list of finished or canceled, this will return true. Otherwise, it will return false for pending or started. Let's go ahead and see this tested out. So on this test page, this one is canceled, and we can see that it's true. This one is not finished or canceled, it's pending, so it's false. For the final example, we're going to create a driver level. This is going to use all 4 of the expression components in one expression. Let's check this out. A driver level is going to be an attribute of a driver. So we want it to belong on the driver table. First, we need to determine which jobs have been assigned to which drivers. Luckily, whenever you do a reference to another table, let's say this driver column is a reference to the driver table, what this does is inside the driver table, creates a related jobs on the other end. This is going to be a list of all the jobs that are related to that driver. As we can see, each of these drivers have a list of jobs for each of them. We want to take this column and wrap it in a count function. The count function takes a list of items and converts it to a number of the count of items inside that list. Let's go ahead and check that out. Since this is an attribute of the driver table, let's go ahead and create a virtual column right here in the driver table. We'll call this driver level. In this virtual column, we're going to go ahead and type in the function count. Within that count, we're going to put in the column jobs. This currently returns the number of jobs assigned to each driver. This is an important value for us to save. So let's just hit enter a few times to put it aside. The main function we're going to be using in this expression is the ifs. The ifs function is a conditional function, meaning based off of a condition, it returns a different value. For the first condition of the if statement, we want to go ahead and copy this count of jobs and paste it right there. We can get rid of that initial one. So if the count of jobs of this driver is greater than 20, we want to return the value of platinum. This would mean that this driver is a platinum driver. We want to go ahead and copy this expression and paste it down below. Now, if that driver has completed more than 5 drives, we want him to be gold. Paste it again. If he has completed more than 1 job, we're going to say silver. And then last, if they've completed what is equal to 0 jobs, then they are going to be bronze. Since this is the end of our expression, let's go ahead and remove that last comma. So to convert this function into English syntax, let's say like this. If this driver has more than 20 jobs, return the value platinum for their level. If they don't, but they have a count of greater than 5, then gold. But if it's not greater than 5, but they do have a count greater than 1, then return silver. But if it's not greater than 1, but it's equal to 0, then let's return bronze. Let's go ahead and test this. We remember that the top 3 right here all had 7, 7, 7, and 6, and then 6 again. Let's go ahead and scroll down to these people who are silver. These people have very few drives. Last, we're going to go ahead and add myself as a user to see if I end up being bronze. Let's hit save. Now, if I go to the driver view and add myself, let's go ahead and say Cameron, noob, and put in a fake phone number, hit save. Scroll down here, Cameron noob is a bronze driver because I have 0 jobs. If you've enjoyed this video and would like to see more content like this, please subscribe and like this video. Also, if you have any remaining questions, please don't hesitate to leave a comment down below. We'll make sure to get to you. We appreciate you joining us for this video and hope to see you again. Bye.